So water quality checking for bacteriological purpose and chemical purpose is a must.
The consequences of water misuse are many and they are serious. The Prime Minister of India expressed his concern and that of his government in his address to the National Water Resources Council on the 1st of April 2002. The solutions that the Prime Minister offered to meet this challenge only point in one direction. We need to consciously plan and regulate our water usage in all areas, whether it is required for irrigation, industry, or for our personal needs. So, the conclusion is that we need to manage our water resources more efficiently. And for that, we need to look at the science of water, technically called hydrology. Hydrology deals with water in all its forms, looking at both the quantity and the quality of water. Efficient management of any resource requires adequate and reliable data. For a scarce resource like water, the availability of data are even more critical. To obtain data, measurements need to be taken in the field. For this purpose, there are observation stations such as rainfall stations, climatic stations, river gauging stations, and groundwater stations. The recorded data are then computerized and stored in data libraries. Planners, designers, and others such as farmers, industrialists, or consultants can use this information to manage the available water resources. This total process of data collection, computerization, data storage, and dissemination of the data to the users is called the Hydrological Information System, or in short, HIS. Data about water resources have been recorded for many years, but the data were limited in coverage and scope. Even recorded data were difficult to access at times.
Earlier, we used to have this data from all these files and papers we have to write down, and now this data is being made available to us in the floppies and disk formats. That has become very easy for us.
The limited availability of data did not lend itself to the accurate designing and planning of the country's water resources. To improve this situation, the government decided to set up a more complete hydrological information system. A beginning was made in late 1995 in the form of the Hydrology Project, covering all aspects of the hydrological information system in 9 peninsular states of the country. Work on the hydrological information system has been continuing ever since.
We didn't have until mid-80s the concept of integrated water resources management or an integrated river basin planning and management. It's just about taking shape. And if you want to have an effective integrated water resources management, what we call IWRM, or integrated river basin planning and management, you need a large amount of data, a credible data, and authenticated data. We thought only a proper scientific hydrological information system would be able to provide this data. That was the motivating force at the time.
This improved hydrological information system has ensured efficient data collection by using state-of-the-art observation equipment, effective data recording with the help of computers, easier access to the information for the users through the internet. As a result, reliable hydrological information on both quantity and quality is now easily available to planners, water managers, researchers, farmers associations, and anybody else who could use such information to manage water.
Now the internet facilities are available at village level also. The farmers will be surely using the internet facility for acquisition of the data from the HIS, and that will facilitate them in their day-to-day farming activities.
The hydrological information system monitors the quantity and quality of both surface water and groundwater and meteorological factors. Surface water is all water around us which is visible on the surface, such as rivers and lakes. Under the hydrological information system, surface water is measured using a variety of instruments.
ये एचपी के अंडर में गए उसी से हमको ट्रेनिंग बहुत मिल गई.
Under HP, I was trained in everything about measuring rivers. Earlier we used to take measurements with the float, but now we were taught to accurately measure river currents, water velocity with a current meter. We know every detail about what instrument to use, when to use it to measure water velocity in rivers. For instance, for low water levels, we use this pygmy current meter. Then we go on a ropeway to measure river water velocity when the water levels are high.
वो सब हमको अच्छी तरह सिखाया.
Groundwater is water which is available under the ground. Groundwater resources can be accessed through wells. Though this water is not visible, it is important that it is measured, a job which people working in the hydrological information system take very seriously.
This is a piezometer. Piezometer is to measure the water level. This water level comes when we apply the irrigation water to the crops. It is a open bore well, and we constructed this in Hydrology Project under Hydrology Project.
Meteorological factors are weather phenomena such as rainfall, sunshine, wind, and humidity. These factors are important to be measured because they indicate the water loss by evaporation. Under the hydrological information system, meteorological factors are measured in full climatic stations.
The full climatic stations gives you the climatology regime of the country. It helps to decide what type of crops you should grow, what type of reservoirs or river valley projects you should develop to make the best use of water availability.
Under the hydrological information system, both surface water and groundwater are tested for quality. For surface water, this means taking samples from rivers and testing these either at the location or in a laboratory. To test groundwater, samples can be taken from wells or springs, as these represent the groundwater quite accurately.
Unless we have the data, we cannot plan any action programs for restoration of water quality of the natural water bodies. That is the main problem we faced. We need data.
Under the hydrological information system, 80 water quality laboratories have been set up. These